Welcome to Summarize Science. Today we are looking at a fascinating paper that asks a simple but profound question. Do language models actually track entities across state changes? If you tell an AI that a peach is in a box and then tell it to move that peach, does the AI maintain a constant mental map of where that peach is? The researchers investigated how non-toy, professional-grade models like Llama and Gemma handle these natural language tracking problems. To test this, they used a specialized box dataset where objects are placed in, removed from, or moved between 7 different boxes. An example might include placing an apple in box 0, then a watch in box 1, and eventually removing the jar from box 2 before asking what is in a specific box. One major discovery is that AI models do not track world states incrementally as they read each token. Instead of building a map as the story unfolds, they simply aggregate all relevant information at the very last moment when the query becomes evident. They use linear probes to look inside the model's layers and found that the AI isn't really thinking about the box contents until it absolutely has to. This means the model solves a fundamentally sequential task using a non-sequential, parallel strategy. The study identified specific circuits or groups of attention heads within the model that are responsible for adding objects to boxes. They found that adding an object involves passing positional information, like where the object first appeared in the text, to the final decision-making layer. Interestingly, different models use different sets of heads to perform this task, but they all rely on similar underlying subspaces. This suggests that the mechanism for tracking where things are is somewhat universal across different AI architectures. Things get even more interesting when looking at how an AI removes an object. The researchers found that models implement a remove operation using what they call a fragile global suppression tag. Instead of logically taking the item out of a specific box, the AI basically marks that object with a hidden tag that tells it to ignore that object everywhere. This is a bit like trying to forget a specific person exists entirely just because they left the room. Because this removal mechanism is global, it leads to some very specific failure modes. For instance, if an AI is told to remove a hat from box 0, it might accidentally stop predicting the hat exists in box 3 as well. This degenerate behavior confirms that the AI isn't really tracking the location, but is instead just suppressing the word hat globally. The researchers even found that manually removing these tags from the model's internal processing could partially fix these errors. To recap, the researchers found that modern AIs do not keep a constant, updated map of the world in their heads. They reconstruct the world on demand, which makes their logic brittle when objects are moved or removed in complex ways. This suggests that current AI architecture has a significant bottleneck when it comes to long-term, complex reasoning. In the future, developers might need to encourage models to latently compute world states in the background to avoid these mistakes. Understanding these hidden tags is a huge step toward making AI more transparent and reliable for real-world tasks. This study shows us that while AI can seem human-like, its internal logic is often much simpler and more mechanical than our own. Thanks for watching Summarize Science. Be sure to like and subscribe for more bite-sized breakdowns of the latest breakthroughs in tech and science.